A very good morning to all of you. Today we are going to cover the gray level transformation in DIP, digital image processing. In last lecture, we covered the intensity transformation and spatial filtering. This is the further topic of transformation, that is gray level transformation. As we know, gray level or gray level value indicates the brightness of a pixel. An image is consist of millions of pixels, and every pixel has its own gray level. As we know, there are two types of images, 2-bit image or 8-bit image. If we consider a 2-bit image, there are only two color pixels available. One is 0 for black and one is for white. Suppose we having this pixel chart. Okay, so here we are displaying only two pixels, 1 and 0. So here clearly 0 represents black color and white represents white color. So there are only two options available in this diagram. But if we take an 8-bit image, considering an 8-bit image, so the grayscale level will varies from 0 to 255. So they have the mixture of colors from 0 to 255 range. So again we are considering a different grid. So here the value will vary from 0 to 255. Suppose here is 0, 1, 3, 8, 38, etc. So suppose we are considering 55. So 55 is a mixture of white and black color. If we mix white and black and the new form is 55, so it is a mixed gray color. So this is nearby 0, so this is a blackish gray color. And if we move towards 255, so that will become whitish grayscale color. So as we move towards the 255, this image will become more bright. Okay, so this is the introduction of grayscale image. Now come to the transformation, gray level transformation. There are 4 different types of transformation available. One is point transformation, linear negative identity transformation, algorithm transformation, power law transformation. First is point transformation. So when we talk about the point transformation, so we get the S is equal to T of R. S is the output and R represents the input signal. But point transformation is always work on pixel to pixel. So we'll consider only one pixel and transform the single pixel and change it. Okay, so where T is a transform operator and they may be done by using 1 cross 1 window, that means only a single pixel. Thus, this type of transformation is known as point transformation. So this is a journal diagram for gray level transformation. If we consider all the 4 cases in this, so we can easily understand this diagram. Here, this line, the diagonal from L minus 1 to L minus 1 shows the negative point. Okay, if the output is completely superimposed over the input, that is called identity transform. This represent the log transform and this represent the inverse transform. Okay, so this is the journal diagram for gray level transformation. For second is linear transformation includes simple identity and negative transformation. If we talk about the simple identity, it means every input is superimposed over output, exactly same. Each value of input image is directly mapped to the each other value of output image. That results in the same input image and output image, and hence called identity transformation. That's why this is called identity, because the input image is similar like the output image. Next is image negative. Image negative of an image with intensity level in the range from 0 to L minus 1 can be described by S is equal to L minus 1 minus R. Here L value is 256. So 256 minus 1 is 255. The value vary from 0 to 255 minus जो भी आप input consider कर रहे हो. ठीक है, this is for negative image. Log transform, the general formula for log transform is S is equal to C of log of 1 plus R. So here C and R are the constant values. Okay, C value, it can be anything, 0, 10, 1, 11, 50, 100, anything. As much as the C value will change, the brightness of the image will increase. Okay, so this is for log transformation. Here C is a constant and R is greater than equal to 0. Maps a narrow range of low intensity value in input to a wider output range. The opposite is true for high density input values, compresses the dynamic range of images with large variation in the pixel values. And the last one is power law gamma transformation. The formula for power law gamma transformation is S is equal to R C R raised to R gamma, where C and R gamma are positive constants. Power law curves with fractional values of gamma map a narrow range of dark input values to a wider range of output values. The opposite is true for higher values of input levels. There exists a family of possible transformation curves by varying gamma. Okay, I hope you understand the topic. Thank you very much.